Okay, we're going to look at our last kind of problems that we had, which were the significance testing problems. Again, for proportions and for means, and then we'll use the charts and we'll also use our calculators. So this first problem says the state Fish and Game Division claims that 75% of the fish in Homestead Creek are rainbow trout. So right away, I see the 75%, so I'm probably thinking this is about a proportion. Doesn't say average, doesn't say mean, it has a percentage, it talks about things like that. So probably a problem about a proportion, which will be important. However, the local fishing club caught and released 200 fish in one weekend. They found 170 were rainbow trout. Does this indicate the percentage of rainbow trout is more than 75%? So we definitely have a proportion problem. We're seeing if it's more than 75%. So we'll start off by writing our hypothesis. So we have a null and alternative. And very important, when you do a proportion, you're going to put P here. If it's a mean problem, we'll put mu. This one's P. So the proportion that's claimed is 0.75. 75% as a proportion is 0.75. But we think that's incorrect. We think it is greater than 0.75. Now, to try to prove that it's greater than 0.75, we sampled 200 fish that we got from this creek, and 170 were rainbow trout, which works out to be 85%. Now, that's definitely bigger than 75, but the question is it big enough to prove that all the fish in the creek are more than 75% of them are rainbow trout? That's the big question. So we're going to try to do it. If you're doing it by hand, we are going to kind of draw a curve. Now the mean is always going to be whatever your null hypothesis is. So the mean is 0.75. So 0.75 will go in the middle. And our value is 85%. So 0.85, because that's the number we came up with. So this shaded area here, this is going to eventually be my p-value. And we don't know what that is yet, and we can't really figure it out because we don't have the standard deviation of the sampling distribution yet. Now, if you're doing this by hand, you definitely will have to use this chart, which is the final exam formulas. And you can see it says standard deviation of sampling distribution for p hat, for a proportion. So we will use this formula. So to get the standard deviation of the sampling distribution, you would have to use that. So if we jump back over here, the standard deviation of the sampling distribution is going to be square root of p, which is 0.75, 1 minus p, which is 1 minus 0.075, over the sample size, which is 200. So we'll just figure out what that is. We'll jump over here to the calculator and we'll just plug those numbers in, see what we get. 0.75 times 1 minus 0.75. And again, this is just that formula I got from the chart, divided by 200. So I'm going to get 0.031. I think that's sufficient. So now I have the mean and standard deviation of the sampling distribution, and I want to find the test stat and p-value to basically see how rare this sample is if the null hypothesis is true. So my test statistic, remember test statistic is standard score or z. So z is just 0.85 minus 0.75 over 0.031. So if I figure that out, 0.85 so 0.85 minus 0.75, this is just figuring out that z value, is 0.1 divided by 0.031, should be 3.1 if I'm not mistaken. 3.1, 3.2. So our z is 3.2. So now, if I'm doing this by hand, I'll have to use the chart. So I go to the chart, and for 3.2, you see the value is 99.93. Now, the good news is that 99.93, that is always the area to the left. So this area is 99.93. Our p-value is the value above. So for our p-value, in this problem, we'll do 100% minus 99.93%, which is going to be super, super, super small, which is 0.07%. So we get a really, really, really small p-value. So the big idea now is we want to make a decision, reject or fail to reject based on what we have here. So our p-value is really small. It's only 0.07%. So since the p-value is less than 5%, remember 5% is that level of significance that we claim if one's not given, we reject the null. If p is really small, we have evidence against the null, and our conclusion would just be there is evidence to show the proportion of trout is more than 75%. And that problem is done. So on a test, this could be a multi-step problem. Make your hypotheses, find your mean and standard deviation, find your test stat, find your p-value. You guys have to do all these things at once. Now, the nice thing, if you do want to use the calculator, it won't do your hypotheses for you, but what it will do is it'll jump down and find this z and find this p-value pretty easily. So on the TI calculator for a proportion, if you recall, and they did a pretty good job of this in the notes talking about this, this is a one prop z test. We did one prop z interval yesterday with the confidence interval. This is a one prop z test. So if you go to stat and over to test where it says one prop z test, it'll just ask you questions. Now p naught or mu naught, depending if you're doing a mean or a proportion, this is always just the number that goes into my hypothesis, so 0.75. This says how many out of how many for the sample, which is 170 out of 200. So I'll put 170 and I'll put 200. And our hypothesis is going to be greater than, because that's what I picked for this problem. We were seeing if it was greater than 75%. I will hit calculate, and you can see this gave me a z of 3.26. We got 3.2 by hand, so very similar. The p-value is the second one, 5.45 e to the negative 4, so that's 0.000545. So that's about 0.054%. We got 0.07%. So very, very, very similar. Now, if you want to do a mean test in the calculator, because we're not going to need to do it on the next problem, as you'll see. So proportion is this one. If you're going to do the mean, same idea, but the function on the calculator is z-test. It's the very first one. So very handy, and even if you're doing it by hand, you can certainly check your work on the calculator and make sure you're getting the same value. Now the second problem I have here, similar stuff. I kind of made it a little different where it is, it's a problem where it has kind of calculator screens to pick. This is a pretty common way to see problems on the final, so a good one to practice. So this is a company makes cola drink, states the mean. So that's a pretty big clue. This is a problem about a mean. Mean caffeine content per 1 12-ounce bottle is 40 milligrams. We believe this to be false. During your test, you find a random sample of 30 12-ounce bottles of cola that has a mean caffeine content of 39.2 with a standard deviation of 7.5. At alpha equals 0.01, so our level of significance in this case is 1%. Normally it's 5 unless they tell us. Does this indicate you're correct and the mean is not 40? So, same idea. We'll write a null. We'll write an alternative. So mu is equal to 40 is what is claimed. We just don't think that's right. We think it's not 40. Now we have 6 calculator screens here. Then one of these is going to be the one that represents our test, does all the math for us. Now, really easy to pick out the correct calculator screen. Just look at your alternative hypothesis is. So if you look here, the one that has that matching alternative hypothesis is this middle one in the top row, because it says mu not equal to 40. Now, once you have the calculator screen, it really tells you all the information. It says, what's the test stat? Well, the test stat is z. It's literally given to you. So negative 0.58. And it says, what is the p-value? Well, the p-value is just p. So the p-value is really, really big in this case. It's 0.559. Now, to reject the null, that p-value has to be less than 1%. That's 55%. This is 55.9%. That's definitely not smaller than 1%. So we would fail to reject since the p-value is greater than 1%. And again, it's just 1% because this problem said 1%. If it doesn't tell you, just use 5. So what's the context? The context, we would just say there is not evidence to show the mean caffeine is not 40 milligrams, I believe. Okay? So we have a follow-up question for this one. It says, what would a type error one be in this context? Well, a type 1 error, if you call, means we're going to reject the null when it's true. So our null said that mu is 40, so rejecting it would be, so if I'm saying that's not true, and that mu is not 40, but that's the wrong decision. So a type 1 error would be concluding the mean caffeine content is not 40 when it really is. And if you recall, we really don't know if we're making a type 1 error. It's just an error that could be committed in our calculations. You never really know if you are. We just try to reduce the chances of it occurring with our level of significance. So hopefully these are helpful for you as you prepare for the last exam of the course.